Welcome. I'm going to discuss a little bit distribution of mass, center of mass, and balance. Within that, you also have the discussion of nose-heavy or tail-heavy distribution of mass. Whenever people use those terms, they exist separate from balance. Balance is like the final result of the distribution of mass. And the center of mass is also the final result of the distribution of mass. So whether a design is on paper or in your head, you should have these basic parameters in mind because they're known. There's no theory involved in airplane design. Not in a conventional airframe there isn't. The science is well understood. But I've actually got a little teaser here, or just something I wanted to mention. On this drawing of the 172RG, the thrust line looks really good to me. It goes right through the fuselage, and the horizontal stab is just about right on it. That looks like a really good design to me. Although something that's common to, at least to Cessnas, and they have some of the most attractive designs in my opinion. They all have an extra 3 or 4% of height on the vert stab that a model does not need, as well as this dorsal fin here. It can be reduced to something like I've showed here if one so chooses. All my tutorials are based on normal air model airplane or full-size aircraft that are correctly designed and constructed. Foam board does not qualify. Solid foam does not necessarily qualify. Manufactured foam, all foam planes have a wonky distribution of mass, and it's difficult to alter. So just bear that in mind if you're trying to apply this to what you're doing. You might have to interpolate or not do it at all. Anyway, that's what I wanted to say about the 172. Here's the rest of the text and the illustration that goes with today's discussion. Getting back on track. When thrust line is mentioned, it's just a simple idea of the force that's coming off the prop. And it's going to be perpendicular in orientation to the prop. So when one is looking and imagining or drawing on paper, prop orientation establishes the thrust line, whatever is perpendicular to it. So depending on the model, that can be varied. But for today, we're just talking about a 0-0 thrust line, just a plain old normal thrust line. So that shows in this diagram, I thought it was I had a thought, but it's no longer relevant. This thrust line is pretty good. It's coming out in the low part of the tail. It looks like the wing is mounted at 0, so there's no built-in lift generating functions. The pilot can select for those in trim. That's the way to have a versatile model, is to make it for a normal thing, optimal design, and then trim it. If you want to fly it slow or fast or light or heavy, in windy conditions or calm, indoors or out. When talking about the center of mass, it doesn't exist until the airplane is built, and then it's the result of all the design decisions and construction. So the shape, God dang, the shape of the fuselage is the imaginary shape of the volume located at the CM where mass should be added on to blend in with the leverage that happens within the geometry of a fuselage. Some folks may have noticed, but this 1:3 proportion that's in there ends up giving you a 3:1 leverage ratio factor here. So a little bit of weight equals a lot over here for balance. And guess what? In GA, you get a big heavy engine here. And one of the primary functions of the tail is to counterweight this short arm with a little, just enough weight, far enough aft, but you don't just plunk blobs of weight here and there, if possible. You add the components for power and control in around this volume inside that is centered on. It's a hyperbolic. Oh, it's just a teardrop, okay? It's just a sideways teardrop, but the focal point, is like there and there. The focal point. In terms of its symmetry, as far as I can, that's the best I can say it. So, putting weight for a GA, a full-size design, this everything is normal here, and this is day to day. This is fine. But for a model, we can make this lobe a little lower, a little fatter, if we want to increase the keel effect stability and make it a little more stable, a little more beginner friendly. It should be possible to tune this configuration for more sporty flying by keeping the axis of the CM volume right on line or just below, just a hair below the thrust line. Again, so it's gravity. You see, gravity is pulling everything down. Everything is hanging from the wings when the bird is in the air. And that's where the CG is understood to occur. But an airplane has this pendulum. It's like a pendulum effect. If you strip everything away and looked at a hang glider that's sort of shaped like an airplane, you've got 150 pounds of man directly below the point where that mass needs to be, and almost anything can fly if it's configured correctly. As we've seen, things that aren't correctly still fly, and things that are made out of popcorn fly. I mean, it's ridiculous what things fly, but whether they're flying well is partly opinion and partly science. If one understands these things, when you see it flying in the sky and it looks wobbly or like it's flying sideways, maybe it is, and maybe your geometry is wrong, maybe your distribution of mass is wrong, not optimal. So, when, let's see, I should probably, YouTube keeps hassling me. I'll call it good for their for now. Again, I would remove this dorsal crap here and reduce the height by about 3%. Thanks.